Most of the time we use a formula to find an answer, but sometimes we have to use a formula to find part of the question. This problem here is a good example of that situation. You were observing the sales department using exponential smoothing. Now, before we go any further, that's what I mean by a formula. Exponential smoothing. The formula for exponential smoothing is that your forecast for a certain period equals your forecast for the period before, capital FT minus 1, plus alpha, a smoothing constant, times what actually happened the period before, minus what we had forecast would happen in the period before. Okay, now we hadn't gotten any farther than this first sentence yet in the problem. What does it say? Okay, the sales department, their forecast for January sales, I think we're going to need this, was 12,000 units. January's actual sales figure became available yesterday. It was 10,000. Today the sales department announced their sales forecast of 11,300 for February. What's the question here? What is the alpha they're using to forecast sales? Oh, right, alpha. The question is not asking for us to fill out this formula to find a forecast. That's what you normally use the formula for exponential smoothing for. It's rather asking us what this number right here in the formula should be. All right, well, apparently we have enough information to track that down from what we're told. One of the things that I want to do next is I want to relate this formula, the general formula, to the specific situation that they're discussing for the sales department. And what I mean by that is I noticed that they're talking about January and February here. Oh, so the forecast for February, if they were using exponential smoothing, and it says that they were, would equal the forecast for January. You know, instead of just writing T and T minus 1, I'm writing February and the month before that one, January, plus alpha times what actually happened in January minus what I had forecast would happen in January. All right, now at this point I haven't determined anything. The only thing I've done is rewritten the general formula just in terms of January and February. Why did I do that? Because now I can piece together the answer to this question. Okay, the problem says their forecast for January sales was 12,000. Their forecast, capital F for forecast for January was 12,000. The 12,000 goes there. Oh, wait a minute, and here's the same thing. The forecast for January, it also goes here, so to speak. All right, there's that number. January's actual sales figure became available yesterday. It was 10,000. Capital A for actual in January. Here's where the 10,000 goes. Okay, so their forecast for February would have been that 12,000 plus alpha times 10,000 minus 12,000. Let me complete the bracket. Except we have another number here to use. The sales department announced their sales forecast as 11,300 for February. Their forecast, capital F, for February, this right here was, that's where that number goes. 11,300. Oh, what's the alpha? Notice that alpha is now the only thing that's not known here. All right, so we can just track it down algebraically. Let me think. If I subtract 12,000 from both sides, I'll have a negative 700 over here, but it'll disappear over here. And then 10,000 minus 12,000 here in the parentheses is a negative 2,000. So I basically have a negative alpha times 2,000 over here. All right. Divide both sides by a negative 2,000, and I have a negative 700 divided by a negative 2,000 over here. And I'm really relieved because a negative divided by a negative is a positive, and alpha needs to come out positive. It doesn't make any sense if it came out negative. All right, 700 divided by 2,000, 0.35. They must be using, apparently, an alpha of 0.35. Right, alpha of the smoothing constant should be something between 0 and 1. So that we were anxious by the time we got to the bottom of this problem that we get some number that's between 0 and 1.